Meet a very smart octopus.
Oh, look, he got in. He got it open.
And see how an ear
Gigantic.
keeps whales out of trouble.
I'm Alda. Join me in the Creatures of the Deep on Scientific American Frontiers.
Presentation of Scientific American Frontiers is made possible by a grant from GTE Corporation. At GTE, it's amazing what we can do together.
What do you think? Are we there yet?
Yeah, we're just about in the canyon now.
We're less than 10 miles offshore from Monterey, California. We're just coming up to a place called the Monterey Submarine Canyon, which until recently was almost completely unexplored. I'm going downstairs.
Take care.
It's sometimes said that we're less familiar with the Earth's oceans than we are with the surface of the moon. And there's a lot of truth to that. When this research team started studying the Monterey Canyon 6 years ago, they immediately began discovering strange new creatures that were completely unknown to science. We're going to take a look down there in the canyon, and who knows, we might discover a new species. First, we're heading 2,000 miles across the Pacific to meet a more familiar but much scarier kind of creature.
The balmy waters of Hawaii. Tourists by the tens of thousands splash in these waves every year, while just below them glide hundreds, perhaps thousands of the deadliest killers in the ocean. Every now and then, shark and human meet.
This morning, a BYU student was attacked by a shark while surfing.
As predictable as the breathless media coverage are calls for shark control programs that would literally fish the killers out of Hawaii's coastal waters. Which is why this University of Hawaii research vessel regularly sets out from Honolulu Harbor.
You can't actually dictate the size of shark you catch by the size of the baits you use, so a good big tuna head, nice and bloody, just what we need.
Kim Holland and a team of graduate students are baiting lines to catch tiger sharks, the species that poses the greatest threat to Hawaii's humans.
Yeah, that's a tasty morsel.
But the team isn't fishing for sharks in order to control them. They're on a research mission to find out if tiger sharks can be controlled and what the consequences of killing them might be. The baited hooks are left out overnight. When morning comes, the research crew gets an extra hand for the day.
Okay, Aaron, do it. Oh, man, you've done this before.
As we headed for the first line of hooks, I asked a question I've always wanted the answer to.
Is there any evidence at all that there's such a thing as a killer shark? A shark that goes after humans?
No. In terms of the tiger sharks, and as far as I know with other species of shark, there is no evidence of that whatsoever. And you think about it, sharks evolved in the ocean. Man did not evolve in the ocean. If they'd evolved eating man, or mankind, they wouldn't have gotten very far, because until the tourist industry hit, there wasn't very many people in the water. You can't make a living eating something which is not in your realm.
What about if a shark bites a human?
Which doesn't happen very often.
Right. How often does it happen?
In the state of Hawaii, it only happens maybe twice a year. And when you think of how many people there are in the water all year round, and how many sharks
are there in the water?
There's a lot of sharks, because we catch sharks all the time. There's no problem.
The interesting thing is, with all of those sharks, there are only 1 or 2 bites a year. Now, how many of those bites are fatal?
Good point. Very, very few. In Hawaii, in the last 30 years, only 3 attacks have been fatal.
All that didn't sound so bad. And the first shark we hauled in looked reassuringly harmless, especially when Kim rolled it onto its back.
You can turn it over like this. These fish go into what we know as tonic immobility. So even if this fish wasn't very tired, it would basically go to sleep in this position. On the nose.
It was a 5-foot-long sandbar shark, not a species much given to biting humans.
What Carl's going to do, try and do very carefully now, is take that hook out of her mouth. Well done, mate. And then we're going to let her go.
Is there any relationship between these smaller sharks and the tiger sharks?
One of the few things we do know about tiger sharks is one of their main foods is smaller sharks. So if you kill the large sharks, the number of medium and small sharks will probably increase. Their food is frequently the commercially important fishes. So by affecting the top predator, you may end up perturbing ecosystems such that the commercially valuable fish will decrease in numbers.
So trying to rid Hawaiian waters of tiger sharks could reduce the populations of fish Hawaii and its tourists like to eat. It was beginning to sound as if tiger sharks don't deserve their reputation. Of course, I'd yet to meet one.
Okay, we got a tiger shark on this line.
Good.
And it's alive, and it's a medium-sized one. Here it comes right now in the water behind us. Well, that's a big one.
How long do you think he is?
It's about a 13-foot long shark.
13 feet. And now, would you say he's tired?
It's just the way we like him. He's still obviously very healthy, but very tired, so we can work with him, put a transmitter on him, and let him go. He's safe, we're safe, we get what we need. This is just the way we like him.
Let me ask you a serious question here. When the shark has that hook in its mouth,
Yes.
is it just as able to bite as without the hook?
No. And the other thing you have to realize is that sharks don't use their mouths for defense or for aggression. Their mouths are for feeding. So it's not like a dog that is cornered and strikes out at you with its mouth. These animals don't think about taking their vengeance out or being so frightened they come and bite you. All this shark wants to do is get that hook out of its mouth and go about its business.
And it was finally time to go about our business, which was to tag the tiger shark with a radio transmitter so that we could track it. Killing the tiger sharks around Hawaii's beaches would control the threat they pose only if they don't travel very far. And until this research project, no one has known how far tiger sharks roam. It was time to meet the tiger face to face.
That's a gigantic head on this,
Yes.
this shark.
It's like a big tadpole.
It's doing what?
It's biting the boat.
It's biting the boat. That doesn't sound like what you said before about not biting
Well,
things that aren't food.
that's the great thing about science. It's a world of discovery.
Like the little sandbar shark, this one was supposed to go into a trance when belly up.
You had her over on her belly. How long you have to keep her on her belly for this effect to take
It
place?
varies, but usually just 3 or 4 minutes and she'll go quiet.
Oh, 3 or 4 minutes?
Yeah?
Oh, I thought it was a couple of seconds.
No, well, it depends. Sometimes it can be. There she's going now. Okay. See, there she's gone now. As long as we can keep her belly up, she'll be all right. Like that. Hey, rub her tummy.
Does it make any difference if you rub her tummy? I mean, does that help her quiet down?
I don't know. But, you know, it's a very, very common phenomenon in all vertebrates.
Oh, gee. Oh, boy. That's like, I'm playing the part of Richard Dreyfuss. Oh, is he busy today?
And if you'd like to, after Brad makes this...
After they'd made the shark really mad by sticking a knife in her skin, I got the privilege of implanting the radio transmitter.
You're welcome to put it on if you'd like.
All right.
Here's the transmitter.
What do I do with this?
We're going to put it right in that incision, right on the back of the shark, right here where we made that small incision, right there. That's it. Right in that hole, right there. Push. Beautiful. Give it a knot. One more knot. There you go. A little bit more. Perfect. There it is, right there. There's the transmitter in place, and we can follow her wherever she goes. Because it's a depth-sensitive transmitter, we not only know where she's going sideways, but how deep she is, whether she's near the surface, near the bottom, 10 meters or 100 meters deep. That's perfect. You should do this for a living.
No, I shouldn't even do this for a living.
The shark and I weren't unhappy to see each other go. Now came the easy part. Kim lowered a directional antenna below the boat.
Okay, if you just wag the nose, we should start picking up the signal. There it is. That's our fish. That's the transmitter. And it's at the surface because it's very steady once per second. If it was deeper, it'd be faster.
I see.
So our fish is now dead ahead of us at the surface. Okay, this fish is doing about a 100-degree course right now, which is going to take us right off the tip of Diamond Head, which is a very familiar theme for us. Three or four of the previous sharks we tracked have come along exactly this path, cut off the tip of Diamond Head, and then strike out into blue water between here and the next island of Molokai.
Typically, Kim and his team stay on the trail of a shark for as long as the batteries in its transmitter last, about 48 hours. They've tracked about a dozen sharks so far, and every one has wandered far away from where it was caught. This was a big surprise, and bad news for advocates of shark control.
What would happen if there was a really bad attack here by a shark and people went out in boats and killed all the sharks, all the tiger sharks they could? Well, what effect would that have?
It probably wouldn't have any effect on the number of shark attacks on people. The reason being that we're showing that these fish move much greater distances than we anticipated that they would. And that means if you take out some sharks from one beach, they could very easily be infilled by other sharks coming from 30, 40, 50 miles away. So at this point, it looks as though it'd be difficult to have a surgical strike.
Okay, look. A lot of people don't care if there are fewer sharks. I mean, I think some of us think of them like rats. If there were a few less rats, it wouldn't hurt. What place in our lives do they hold? Why should I care if the tiger shark disappears or not?
The proliferation of rats is a man-made phenomenon. They live in towns and cities that we've created. Tiger sharks live in an environment which is still essentially unchanged. And as such, they're in balance with their environment, and the balance between them and the food that they eat and the food that their food eats is still pretty much the way we think it evolved over evolution. And so by perturbing the system, by taking out the big sharks, you will actually have an effect all the way down through the food chain.
The tiger shark is just one of 19 shark species that live around Hawaii. All have their mysteries, but none is stranger than this one, the hammerhead shark. A day after wrestling tiger sharks, I joined Kim and his student, Chris Lowe, in Oahu's peaceful Kaneohe Bay, fishing for baby hammerheads.
It's a little guy.
That's the most common top-level predator in the bay. There's thousands of those pups of this size in this bay. So when I drop it in the tank now, we can just run a couple of 100 yards back to the lab and we've got our fish.
How big do they get to be?
An adult scalloped hammerhead would be about 14 feet as an adult.
14 feet, so these guys are really little, they're young, huh?
These are neonatal pups. They've only been born maybe, the biggest one maybe 3 or 4 or 5 weeks ago, and the smallest ones maybe a few days ago.
Okay, now look, this is the most interesting looking fish I've ever seen. Why do they have a head like that? Why is it shaped like that?
Probably for several reasons. One is that they have an eye on each end of the head, so that it helps them with binocular vision. They also have a nostril on each side of the head. Yeah. So that probably helps them to orient to smells in the water. They also have an array of electroreceptors all the way. See those shadows there?
Yeah.
Those are electroreceptors. They can detect the electrical currents emanating from small prey that they feed on that might be buried just under the sand.
The hammerhead certainly appears to use its head like a metal detector when searching for prey. But Chris Lowe wondered if the head's wing-like shape also gives it a lift, literally, when it comes to swimming.
So we can look at this by placing the shark in my swim tunnel or my treadmill for fish.
Water flows through the tank from left to right.
So what happens is I can change the velocity at which the water moves through the loop. And once the sharks are conditioned, they'll swim in place.
This shark always has to keep swimming, huh?
Exactly. I mean, as an obligate swimmer, meaning that from the time it's born to the time it dies, this shark has to swim in order to respire.
Day and night.
Day and night.
Otherwise,
Constant.
what happens?
Otherwise, it'll suffocate.
If you have to swim to breathe, it pays to be as efficient a swimmer as possible. And for the first time, Chris's shark treadmill has allowed him to compare the swimming efficiency of hammerheads to that of sharks with more conventional front ends.
Have you been able to show doing this experiment that the head does give the fish an advantage?
These sharks, compared with other species, are very efficient swimmers. And if you look at, for example, the tail, compare the tail with a hammerhead with another species of shark, the tails are fairly similar. So if the tails are similar, how can the hammerhead be more efficient? Well, the only thing I can think of is their wing-shaped head.
A couple of days with Kim Holland and the students was an exhilarating, if scary, reminder of how much there is still to learn about the creatures of the deep, even such celebrities as sharks.
You know, when we were out in the ocean there, I felt like we were chasing Moby Dick a little bit. I was a little worried, first of all, that he was going to come up and smash our boat apart the way he did in the book. But you're chasing something like Ahab. What are you chasing?
I'm chasing an understanding of how the parts fit together, even when it's a big, ugly part like a tiger shark, which after a while aren't so ugly. But I have a feeling of real urgency about how fast our marine resources can be frittered away. And I and my students are trying to get the kind of scientific information that will allow us to use the marine resources without squandering them, so that they're going to be there for the next generation.
Early morning fog shrouds the harbor of Moss Landing, 75 miles south of San Francisco, as the research vessel Point Lobos heads out to sea. Operated by the Monterey Bay Aquarium Research Institute, its destination is the edge of the last great unexplored region on Earth. Just 10 miles out, the ocean floor plunges into a canyon bigger than the Grand Canyon, poising the Point Lobos over water as deep as almost any in the world's oceans. Below the top few hundred feet, these depths were until recently almost entirely unknown, though by volume they make up more than 90% of the Earth's living space. On board the Point Lobos is one of the first regular visitors to these hidden depths, the submarine Ventana.
What is all this stuff here?
Well, we've got a variety of tools that we use at depth. These are samplers that we use to collect the more fragile and delicate animals. Down here is the big eye. Up here along this middle bar are 4 metal halogen lights. The depths we'll be working at today are very dark. Less than 1/100% of the sunlight which reaches the surface penetrates as deep as we'll be working today.
If you were down there without a light, what would it be like? Would it be like being in a room that just has a tiny crack somewhere under a door? Or...
Even less than that. About the only thing you can see is that looking up towards the surface is less dark than looking down.
Bruce Robeson has been using the Ventana to explore the darkness below for some 6 years now. The submarine isn't piloted. Bruce and his crew operated from the surface, where the ocean's swell is making life distinctly uncomfortable for me and our camera crew. Unfortunately, going below only makes things worse. The control room is small, dark, hot, and constantly pitching. As I munch saltines to settle my stomach, the pilot takes the Ventana on a dive that will penetrate a half-mile into the darkness. The view from Ventana's camera is like something out of Star Wars.
So we're just traveling through space here. It looks like we're in... Oh, what went by?
Complete with aliens.
Oh, Paralia.
What's that?
These are great,
Whoa.
big, brown-colored medusae.
Oh, that's gorgeous.
In a sense, the creatures down here are like aliens.
Look at this guy.
adapted to an environment quite unlike the one the rest of us who live on Earth inhabit.
But this has this big plate at the end of it. What's
This
that?
creature is called a siphonophore.
The propulsive end, and there are two swimming bells, one on either side, that allow the animal to pull itself through the water.
In fact, the siphonophore may not be a single animal at all, but an assembly of many. Until it was seen here in its habitat, no one knew much about it.
You couldn't have ever brought this up in a net, could you?
No, we would have had only bits and pieces. We wouldn't have known how many siphonophores were there, whether it was 1 or 100. These animals get to be extraordinarily large. We have measured them up to 120 feet long. That's a very big surprise.
And it makes it one of the longest creatures on Earth. Capturing siphonophores and the deep's other gelatinous creatures in one piece is a job for one of Ventana's specialized collection devices.
You're going to put them up the vacuum cleaner there?
That's right. We're going to draw this siphonophore into the suction sampler so that we can look at its stomach content.
You can get a big guy like that into one of your containers?
Sure.
And he won't break?
It will be, what's the polite term? Wadded up. Okay,
This is why I don't believe in flying saucers coming down and taking samples of humanity. I don't want to be wadded up by one of those people.
The siphonophores gently sucked aboard in one piece, accompanied by some of the dust-like particles that are everywhere down here.
What's all this snow-like stuff we're seeing around the animal?
You called it by the right name. We refer to it as marine snow. It's sort of all of the junk and detritus and dust of the upper layer of the ocean.
So that's stuff falling off of animals up above, and it passes through this region and continues on its way all the way down to the bottom?
That's right.
And animals are feeding on it all the time?
Yes, certainly bacteria feed on it while it descends, but there are other animals, filter feeders, that occur in midwater, and they process these particles. But eventually they all reach the sea floor.
Since Bruce Robeson and his colleagues began their deep water explorations, they've identified dozens of new species. Creatures down here range from the gruesome fangtooth to the angelic-looking ribbonfish. Some 2,100 feet down, the Ventana passes through a layer where oxygen levels are very low. Among the creatures adapted to hanging out here is the splendidly named Vampiroteuthis infernalis, a distant cousin to octopus and squid. It glares at us balefully through a huge blue eye.
Oh boy, time out. This is a paralipidid.
What's
This is
that?
a very, very beautiful little fish that we don't see all that often. Its nose is up. It's keeping itself almost vertically in the water column. It's looking up, trying to see its prey silhouetted against the surface. Very soon, it's going to take off and it'll be gone just like it vaporized. Here he goes.
Whoa.
He's history.
To evade shadow stalkers like the paralipidid, potential prey are often transparent. Or, like this little fish, they generate their own internal light. When viewed from below, this makes them less visible against the lighter surface. Bioluminescence is used a lot down here. The otherwise black anglerfish has a luminous beard to attract prey. But why so many animals glow in the dark is still a mystery.
This is a red-bellied tomopterid. It's a type of polychaete worm that lives down here. This animal has bioluminescent organs at the ends of all of its legs.
What a good shot that is.
It's like having glowing toes.
There are so many questions down here. This catcher's mitt-shaped creature seems to propel itself along with shimmering hairs along its edge. but otherwise is utterly mysterious.
How does this animal reproduce?
Good question. I don't know.
Well, you know, what's wonderful is how much there is to learn down here.
Oh, sure.
It's a whole other universe.
That's part of what makes it so exciting, because each dive can and often does bring us something new, something unexpected.
Unfortunately, my own curiosity had begun to lose its battle for attention with my stomach.
I think I have to go up and get some air.
Okay.
It's not that this isn't fascinating, but I think staying in one piece will be more fascinating.
Certainly more enjoyable.
Coming up into the air and seeing the ocean again from a more familiar perspective, it was hard to believe so much life lay below its surface.
Even in the black depths of an ocean canyon, nature comes up with a truly fantastic variety of creatures. And they all come about in the same way. Changes in organisms are constantly tested against the environment and against predators. Just up the California coast from here, there's one scientist who's had to develop his own unique way of observing this natural battleground.
Low tide at Pillar Point, a scenic spot on California's coastal highway. It's a favorite spot, too, for biologist Gary Vermeer when he's out searching for insights into one of nature's longest-running arms races. Gary searches, or as he puts it, sees, with his hands and fingers.
Oh, look at this. This is a piesaster. Oh, wow, that is a big piesaster. And he is actually, well, he's very tightly attached.
Blind since the age of 3, it's through touch that he sees things most of us with sight would miss.
What are you doing? Aha. What have you got there? It's like a tegula. Yes, indeed. Absolutely. He had a tegula. Tegula funebralis snail. And he had this snail sitting right like this, and his mouth was over the opening of the snail, and he was clearly digesting it. What they do is they have this stomach that they can extrude through the opening of the shell into the, basically into the snail and digest it externally. It's kind of a slow, miserable way to go, but that's what they do. Just do your thing here. Find another tegula.
It was no contest between the starfish and the snail. But Gary is fascinated by how mollusks like the snail have evolved defenses against their predators' weapons, leading him occasionally to confront those weapons himself.
Yeah, they have some pretty good-sized claws. I got a hold of this claw now. Be careful, you're right. Tips.
Yes. Yes.
Oh, he's really struggling against me, too.
Yes, I'm afraid of getting bitten or something, but it doesn't happen very often. In any case, I think it's worth the effort because you always find something interesting.
To Gary, no shell is without interest, even one that's been almost entirely demolished.
Oh, Colocella asmi on this tegula. This is a lethally broken tegula funebralis. It has, I don't know who killed it or what killed it, but it could have been a crab. And it's been pretty badly mashed. It's definitely a fatal wound.
But it's shells that have survived the attacks of their predators that Gary finds most intriguing. Because in their scars, he sees their life stories.
I imagine a crab where something got at this shell, broke the lip back about 90 degrees. The animal survived and repaired the damage and is now back to normal. But this animal had a rather eventful life.
The daily skirmishes along the seashore that Gary reads in the shells he finds are the latest in a confrontation that's lasted hundreds of millions of years. Back in his office at the University of California in Davis, Gary uses his Braille typewriter to catalog the thousands of shells he's collected in field trips around the world. He keeps abreast of what's happening in evolutionary biology with Braille transcriptions of the journals, including the leading journal in the field, of which he is the editor. Gary Vermeer has never let his blindness stand in his way.
He must have a very, very strong upbringing.
I had an exceedingly strong upbringing. My parents were what I consider to be quintessentially level-headed Dutchmen who they never heard of failure. They never heard of giving up.
On our way to his office, we stopped at a sculpture garden.
Actually, this one looks a little like a crab claw. but the
now,
claws are up high here.
Yeah, now that part's nice and smooth, but you feel this? This is ugly.
Yeah.
It's
see,
rough.
I don't focus on
Yeah,
that because
I know.
I'm
You
looking
see,
at the
when
whole shape.
people look at this, and they don't have to feel it.
Yeah.
They have to feel it. They say, it's just a rock.
Yeah. See, when I
And of course now it's nice and warm because it's in the hot sun.
yeah, well, that's
But-
right. That's something you get that you don't get if you're just looking.
That's
at
right.
it.
You
You're
can't
getting,
feel
you're
the
getting
cold stove.
changes in temperature all
That's
on
right.
the various sides of this.
That's right.
The idea that you may see things that we don't, like this texture and the temperature, things that I would never have thought of as part of the enjoyment of a sculpture is very interesting because do you suppose you see things, therefore, in shells that other people don't see?
I'm not sure I see things that others don't see. I may emphasize some things more than other people would, but I think I essentially see the same things.
We began our tour of Gary's lab with a demonstration of what shells are up against.
How strong are those claws?
Oh, I'll show you here.
This is Ed Pearson, one of Gary's graduate students.
Here, grab onto my pencil here. And give it a little shake.
She's really clamping down now. I can really see how she could break a shell with that strength.
I've ruined a few pencils this way, too, so.
The crab's claws made short work of the snail Ed gave it. But then I got to serve up a different tidbit.
Yoo-hoo. Lunch.
It was potentially as tasty, but in a trickier package. And this time, despite several minutes of probing for a weak spot, the crab gave up and the shell survived unscathed.
That is a pterodactyl.
Yes, it is.
Gary's passion is to learn how these survivors evolved.
Do your shells go back that far or further?
A couple of them. Most of the ones I work on are since the age of the dinosaurs. We go right here. Let me show you a volema that has a truly horrid scar on it. Let's see if we can find it here.
His favorite fossils are survivors who lived to repair their battle wounds.
Here, yes, this is a really dreadful. It has sustained this attack right here, which isn't so bad, and back here when it was much younger. Look at this. This is terrible.
Oh, big crack
just-
like. Now this is all scarred. It's not a pretty shell, and
Nope.
yet this is valuable to you in your work, right?
You bet.
Much more than a pretty shell.
Yes, it tells you a lot. This is an animal that it chronicles its own history very nicely.
The history Gary sees chronicled in his fossil shells is of repaired damage becoming more frequent over evolutionary time, suggesting more shells are surviving the attacks of their predators as their armor becomes more sophisticated. Meanwhile, of course, their predators were evolving ever more fearsome shell-crushing weapons of their own.
This happens to be a box full of one set of stomach contents of a fish.
Now, how did this get broken? Did the fish chew on it first?
Yeah, the fish has a jaw.
Oh,
This
here's
yeah,
the jaw.
This is it. And of course, these are upper and lower, and they crush.
So they crush it between those two
Yeah,
rough
like
plates.
a vice. And it goes just like
Crunch.
But some shells came up with an ingenious solution.
If it has long spines, it makes the shell larger. For example, now this is a truly unusual example. Okay? This
That's
is
pretty spiny.
yeah, it's pretty spiny. Well, these spines actually make the shell, in a way, bigger than it really is. And so it's harder to put into the jaws.
Oh, I see. It's not as the spine. I thought the spine would act like a kind of a spear or a pike or something.
No,
but it's,
it simply makes it
just,
bigger.
It's a bigger thing, but it doesn't have to grow so big. It just puts out little spikes.
That's right. That's right.
Spines aren't the only defense mollusks have evolved. Others grew longer, giving the soft animal inside room for retreat. Some shells evolved buttressing to strengthen the vulnerable opening, while others closed tightly. Or, like this cowrie, have a small opening in a slippery surface. All these adaptations are in response to predators that have also been evolving.
So for animals with skeletons like mollusks, the world has changed a lot. You have to meet higher standards than one might have had to meet hundreds of millions of years ago. You're not necessarily better off today, but it's kind of like human beings. We have to put up with heavier weaponry, with guns, whereas, you know, in the 1200s or whatever, we only had to put up with arrows.
These caught my eye. These are incredibly beautiful.
Oh, yes, they're wonderful fossils.
This incredible beauty was developed through an arms race, apparently, through conflict.
For every organism that lives, an awful lot have died and an awful lot have suffered.
Yeah, you know, I think about the so-called balance of nature in a different way now that you say that, because I guess nature looks like it's in balance and everything seems comfortable unless you happen to be one of the things getting pushed off the scale to bring it into balance.
That's right. I mean, we have to always remember that the world we're looking at is, for the most part, a world of survivors and the world of the successful.
And from that kind of surviving of conflict, you get these beautiful shells.
Yes.
One of my most memorable encounters with a creature of the deep came last year at a fish market on the Bay of Naples in Italy.
Can you eat octopus?
I was there with biologist Graziano Fiorito, who wasn't shopping for dinner, but for subjects to take part in an extraordinary experiment.
Now, what about these guys here?
This is the animal Fiorito works with. The octopus, one of the least loved creatures of the sea. At first, it's hard to figure out just how the octopus is put together.
Where are his eyes?
The head is this.
Yeah.
This is eyes.
Yeah.
From this
What's
side.
this? This looks like a
This
big
is
nose.
the mantle, the abdomen of the animal.
His abdomen, not
Yes.
his nose.
No.
And where's his mouth?
The mouth is underneath. Here
In the
is
middle of
mouth.
all his hands. Mouth is in the middle.
Yeah, here. You see.
Graziano Fiorito takes his subjects back to the zoological station in Naples, Europe's oldest marine biology laboratory. As an invertebrate, the octopus may be spineless, but it is a skilled hunter. Lurking behind a rock, this one is stalking a hermit crab. Octopuses live alone, so it's thought that their hunting skills are partly pre-programmed in their genes and partly self-taught from experience. The idea that a creature as lowly as an octopus might also learn as we do by watching others would be heresy to most scientists. But that's just what Fiorito believes he's seen. Here's the challenge he sets for the octopuses he buys from the market. A glass jar containing a crab and sealed tightly with a plug. Some octopuses, perhaps because they've opened a lot of shells for their dinner, open the jar on their first try. Others, like this one, can be given the jar time and time again without getting inside. I joined Fiorito for the key experiment. The octopus on the right is the one that can open the jar. The one on the left can't.
You already gave him a jar and he couldn't do it.
No.
He could see the animal in
There
there.
are
He
half of population of animals that come from the sea, really, that are able to do. And the other half, they are unable to do.
Oh.
So it depends, let's say, from the individual experience. There is some octopus that are more skilled than other ones.
The unskilled animal will be given a chance to watch how it's done.
Okay, so now the octopus over here in this tank is going to watch this one open
That's
the
right.
jar, huh?
Even knowing how to do it didn't help me.
I need suction cups on my fingers here. I can't do it. Does he see it yet, do you think?
Yes.
The skilled octopus sees the crab immediately and moves in. The unskilled octopus seems to be watching intently as the skilled one explores the jar.
He's crawling now on the jar, and he recognizes the plug,
Yeah.
and he will try. Now its behavior is changed. Now he's carrying back, trying to carry, you see. He will carry the prey back to home to be more safe from the other animal.
He doesn't want the other animal to interfere.
That's right.
The performer pulls the plug and the crab is his. Meanwhile, the observer octopus is scrambling for the best view.
Do you think that this animal, from observing that this time, may know how to do it?
We can try.
Great. Can we see?
Yeah.
Now remember, this animal has never before been able to open the jar. What's new is that he's observed the solution.
Oh, here he goes. Here he goes. Look, 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 look. Oh, wow. Look at him. Just right at it. Oh, look, he got in. He got it open. And he was never able to do this before.
No.
This is unbelievable.
What Graziano Fiorito has shown for the first time is that an invertebrate can learn by observing. Social learning like this is a domain of intellect usually reserved for mammals like us.
He will be not bind.
But as I learned in the fish market, you have to know how to handle an octopus if you want it to show you its secrets.
Why do you need to be relaxed with an octopus?
If you would like to study behavior of animals, the animal must be sure that you would never kill him. There is such a kind of, let's say, good relationship between you and the animal, a good feeling.
You have to have a sure touch, huh? Well, I don't have it. I think these animals can sense it.
Yeah, they are sensitive.
Yeah. What's the best way to pick them up?
Here.
How do you get used to this?
No.
Oh, you like that?
Yeah.
It's a little like
yeah, I beat it.
it's a little like a handful of worms.
The mournful cry of a humpback whale. Racing to save its life is a team of biologists from Memorial University of Newfoundland, led by John Leon. The whale is trapped in a fishing net. Unless it can be freed, it will probably die. This scene was filmed in 1992, at a time when it was tragically common in the fishing grounds of Newfoundland's Grand Banks. The work was difficult and dangerous. John Leon had to repeatedly plunge himself into water just a few degrees above freezing as he tried to free the 30-ton whale. He's been involved in some 500 whale rescues. This time, the struggle has already lasted almost 3 hours. Partially free, the whale is now dangerously mobile. Then with one final cut, freedom. The whale had been entangled in a cod net, and it was as important to save the net as it was to save the whale.
Our fishermen do not earn a lot of money. They have a big investment. They have a very short season. And it's a real tough job. And so when a whale comes and hits their nets right in the middle of fishing season, they might lose enough time that they can lose their whole year's voyage. So it's a serious problem for the fishermen.
But the Newfoundland fishermen were facing an even more serious problem. The near total collapse of a fishery that had sustained this region for centuries. When John Cabot discovered Newfoundland 500 years ago, he reported cod so plentiful he didn't need a net to catch them. As recently as the 1950s, Cabot's claim was believable. But in the decades that followed, local fishermen using traditional dories and much larger foreign fishing vessels had so overfished the Grand Banks that cod nets were coming up emptier and emptier. Just after Frontiers filmed here in 1992, the Canadian government closed down the Grand Banks to all commercial fishing. The decision was a reprieve for the humpback whales, but its intent was to allow cod stocks to replenish so that one day fishing can resume. By the time it does, researchers hope to fully understand why whales apparently don't detect cod nets until it's too late, but rarely get entangled in the finer nets used to catch smaller fish like capelin. That's why Sean Todd of Memorial University is setting out to compare cod nets and capelin nets.
What do you want it to? Shall I give it cleaner?
But not to find out if they look different to whales. Sean wants to learn if they sound different.
What we're doing is we're basically just comparing cod traps, capelin traps, and any other gear we can find in the water and see what kind of sound they make. And hopefully by looking at the sounds they make, we can get an idea of how probable it is that a whale will hit the trap.
Using an underwater microphone, Sean has recorded the sound of dozens of different nets. The sound is made by the water rushing through the net's mesh.
What I'm hearing right now is basically acoustic nonsense. It's just nothing but what we call white noise. It's kind of like a noise. It's just, you can't make any sense of it because our ears really aren't sensitive enough to hear what's going on. But we do have machines back in the laboratory that can work out exactly what this sound is saying.
When the sound is analyzed, capelin nets with their fine mesh are far noisier than the wider mesh cod nets, which underwater are almost silent. This discovery led the Newfoundland researchers to a simple idea: make the cod nets noisier by fitting them with alarms.
If we pull up alongside you, we can give you some alarms and have a chat.
Okay.
In the last year of cod fishing here, John Leon paid a visit to fisherman Ken King. King was trying out an experimental alarm, which was still having problems.
When you haul, do you lift your alarms up and listen to them?
The boys lifted them up Thursday past.
And you can hear them ticking.
Everyone was ticking except the one on the inside end of the leader was a real low tick.
I don't know. We're having some problems with them in the cold water. It's probably, we bought cheap batteries this time. Trying to save a bit of money.
John Leon's experimental alarms didn't save this humpback whale, one of the last to die entangled in a cod net before the fishing moratorium took hold. But its death may help make the alarms more effective once commercial fishing resumes, because buried deep within the whale is the key to the alarm's effectiveness, if only they can get to it. For the whale alarm to work, the animal must be able to hear it. And very little is known about what whales hear for one very good reason. Its ears are buried under layers of blubber. It's not an operation for the faint-hearted when every cut releases the gases of decomposition.
Okay. Oh, geez, watch out. I'm going in. Oh, God. I filled my boots.
But for John, it's all worth it.
Is that coming out?
Well, I think for scientists, it's just amazing how this huge animal works. We only understand it very poorly. And it's a rare privilege to be able to get inside of it like this, even though it's kind of gross, to begin to see how the parts fit together, how they might make the animal work. So it is a little smelly and it's a little bloody and you get wet, but it's absolutely fascinating.
After hours of work, John finally finds what he's looking for, the humpback's ear. To find out if it can hear his alarms, we went to the Massachusetts Eye and Ear Institute.
This is what I call an ear.
And the lab of Darlene Ketton.
Look at that. What a beauty. A whole ear. It's gigantic. All right, so what we've got is the middle ear portion, the bone that makes the middle ear, the eardrum coming out. It's called a glove finger for obvious reasons. And then this is the section that's of most interest to me, the inner ear part, which sits down on here. And then there's a flange, which is currently broken off, but which attaches to that and connects the whole ear to the skull.
Occupying the spot more usually taken by the head of a human patient, the ear is CAT scanned, and the scans are assembled by computer into a 3D image.
Yes, there it is. So here's that inner ear spiral, just sitting right in there as it ought to be, with 2.5 turns to it.
It's this spiral that holds the key to exactly what the whale can hear. Because within it, as this computer graphic shows, there's a flat membrane that vibrates in response to sound.
You can think of it as a whole series of guitar strings of different stiffness and different mass, all strung together, each one of these bits. As it gets narrower, it gets thicker or stiffer. So that's the most taut string. And at this end, it's where it's very thin and floppy, is the least taut string, and that's where the lowest frequency parts are.
To determine the range of frequencies the membrane detects, the spiral is sliced into ultra-thin wafers that can be viewed under a microscope. The alarm John Leon is testing to warn humpback whales away from cod nets rings at a frequency of 4 kilohertz. From her measurements of the membrane and a mathematical model she's devised, Darlene Ketton can confirm that this is an ideal frequency for alerting marine mammals to danger.
What I've done is to plug it into the model, and out of that we get a range that goes, in this case for the humpback, from about 20 hertz up to about 30,000 hertz or 30 kilohertz. It's actually pretty close to what a human hears. So an alarm, for instance, that's around 4 kilohertz to 5 kilohertz is good for the humpback. It's pretty much right in the smack dab in the middle of what it can hear as a total range. It's good for something like a sperm whale, and it's even good for a harbor seal or a sea lion, say, or even a human.
The clinking of the alarm fisherman Ken King was testing before fishing stopped seemed to be successful in warning off whales without frightening away the cod.
Last year when I had a cod trap here in the same area, I was tore up every day. Never missed a day. Had a tear up. Holes in the leader, holes in the trap. And then I contacted John, and I got 7 of these alarms. I put 4 on the box and 3 on the leader. And well, the sound that they made, I thought it would frighten the fish. But the best catch that we had for the season, for one day, at 22,000, the day after we put these things on. I knew it didn't frighten the fish. And for the 6 or 7 days after that we had them on, the fish got a little less because it was getting toward the end of the season, but no more whale holes, thank God.
One day, cod nets will again hang in the waters of the Grand Banks. When they do, the clinks of John Leon's alarms could be a life-saving accompaniment to the songs of the whales.
Presentation of Scientific American Frontiers is made possible by a grant from GTE Corporation. At GTE, it's amazing what we can do together.
Later tonight, KPBS will be celebrating